All right, so we've got another circuit here. We've done one like this before, okay, where we just had R1 and R2 in series with each other, R3 and R4 in series with each other, but all of this is in parallel with all of that. So this is nothing new to us. However, what I'm going to do here is I'm going to make a change and I'm going to install a jumper between there and there. All right? This is realistically what's going to become a bridge circuit, which we'll learn about later. Okay? But for right now, we'll just focus on this circuit in general. The best thing that I can tell you guys is to be able to redraw this to simplify it and see it a little bit better. This jumper changes that circuit considerably. What it does is instead of R1 and R2 just being in series, and R3 and R4 just being in series, and all of this in parallel with all of that, this jumper now puts R2 in parallel with R4, R1 in parallel with R3, and then all of this is in series with all of this. All right? In other words, if I were to redraw it a little bit differently, some people have a better time visualizing it like this. Something like that. So that's R1 and R3, R2 and R4. Okay? Simplify it further. Look at the parallel relationship there. I'm going to do it down here because it'll make a bit more sense to solve it. So that resistor there is the parallel R total of these two. So that's R1 and 3. And then we'll come over here and do R2 and 4 over there. Okay? And it goes back to the source voltage. Now, if I apply values here, we're going to give each of these 10 ohms to start with. Okay? So, reciprocal relationship with these guys, that would be 1 over 10 plus 1 over 10, giving us 5 ohms apiece. Okay? 5 plus the 5 would give us an R total of 10 ohms. And if I said my source voltage up here was, let's say, 10 volts, okay, we then have a current, a line current of 1 amp flowing. Okay? Now, how it disperses within here, we can solve for our voltage drops using our simplified drawing down here. So this is all 1 amp. Okay? We've got 1 times 5 giving us 5 volts. 1 times 5 giving us 5 volts. We can bring that information up here. We've got 5 volts at each of these. Okay? And then we can solve for our current. We'd go 5 divided by 10, giving us 0.5 amps. 5 divided by 10, giving us 0.5 amps. It would all be exactly the same. Okay? So the 0.5 and the 0.5 would then be going up to, or joining together to create the 1 amp there. Okay? This was a simple way of doing it, and this is a simple version because all of the resistances are exactly equal. All right? What happens if they're not equal though? That's when this thing changes a lot. This is what we would call a balanced bridge circuit. In other words, on this jumper, it wouldn't matter if we had it there or not. Okay? So I could erase that and the values would be exactly the same. All right? But if we had different resistances in here, that's going to change the circuit completely. So let's explore that for a minute. All right? So we're just going to erase some of this information. The simplified drawing doesn't change anyway. Okay, so I'm going to keep the source voltage at 10 volts. I'm going to keep R3 at 10 ohms, and I'm going to give R2, say, 20 ohms. Okay, and I'm going to go R1, and then I'm going to go R2 is going to be 20 ohms as well, and R4 is going to be, let's do 80 ohms. Okay, so what that is going to do, well, it's going to force me to use a calculator in a minute here. So we need this relationship there. So we got the 1 over 10 plus 1 over 20. That gives me 6.667. Okay, and then we've got 1 over 20 plus 1 over 80. That gives me 16. All right, so that would then in turn give me an R total of, what is that going to be? We can add the 16 plus 6.667, giving us 22.667. All right, so now we can take that resistance and divide it into our 10 volts. That gives me a current of 441 milliamps. Okay? And that's going to be going down here, but it's going to split differently here. 441 milliamps there. All right? So we can take that current, I'm just going to store it, and we're going to multiply it by our 16 ohms here. And that gives me, what do we got? 7.058. That's my voltage drop there. I'm going to subtract that from 10. It'll just save me one more calculation. And we got what do we got? 2.941. So those are my voltage drops now. Okay, so we got 2.941 volts at both of those and 7.058 volts at both of those. All right, so from there we could take that voltage drop divided by each of these resistances in order to solve for how much current is in each of these branches. So let's explore that. I got a little bit of work here to do. Okay, so I'm going to take that voltage and divide it by 20 to give me 147 milliamps. And keep in mind we had 441 milliamps coming in. Okay, so if we take that value there and I'm going to subtract the 441 milliamps, whoops, hang on, that's not going to work. Okay, 0.441 minus 0.147 gives me 294 milliamps here. Okay, we could also go 2.941, that's my voltage, divided by 10 to give me the 294 milliamps there. All right, so back over here we're going to go 7.058 divided by 20. That gives me 353 milliamps. I'm going to subtract that from the 0.441, whoops. That gives me 88.1 milliamps down here. Add those two together. Actually, we're just going to call that 88. Okay. Add those two together and they end up being that 441. So the last thing that we can look at is how much current is on this jumper. All right. If we had 88 milliamps here, and we needed 294 milliamps there, we know we've got additional current coming down that jumper. Or in other words, it's going to be the difference between the 353 and the 147. Okay, so I can go 353 minus 147 equals 206. Okay? Or we can take the 206 and add that to the 88, and that will be 294. Okay? A better way to look at that, or an easier way to look at that, I know we're dealing with milliamps here, so sometimes it gets a little bit confusing. Okay? If I redrew a simple circuit here without giving any resistance values, but just looked at how current has to balance and flow on that jumper. Okay? So, if I told you that we had 5 amps flowing in here, okay, and that 5 amps, based on the resistance here, we had 4 amps there and we had 1 amp flowing in each of these branches, okay? But then over here, we had 3 amps there and we had 2 amps here. What that would tell me is on this jumper, if we had 4 and we only needed 3, 1 is going down. Okay? Adding up to that one to create the 2. Okay? If this was flipped around and we had 3 amps required down here and 2 amps required up there, my current is now heading up. So we've got 1, sorry, hang on, how we got this going on. What happened here? What did I do? No, it's still going down. My mistake, because I didn't change this at all. Okay? So we've got the 4, we only needed 2, so we've got 2 heading down here. Okay? So in some circumstances, if I flip these around and add 4 there and then 1 there, the current would go up. The current goes where it's required to go. Okay? In other words, what the loads are requiring is going to be where the current flows to. Keep in mind, whatever current started in the circuit has to come back to the circuit, or has to come back to the source, okay? So you cannot just create extra amounts of current. When you get into values like this that are a lot smaller, sometimes there's rounding issues that happen, so make sure you're paying attention to your roundings and don't fret the little details that send it by, 0.1 or 0.2 milliamps off or whatever else, okay? So always look at the total balance. If we looked at polarities on these jumpers now, okay, if this was point A and this is point B, current flows from negative to positive. So in this case, A would be instantaneously more negative than B, okay? Why is that? Because current is leaving and heading down. Same with this one here. Current is leaving that point and heading down there. So this is instantaneously a negative and this is instantaneously a positive. All right? There will be some questions we're going to ask you on that, and it'll become a little bit clearer when we do bridge circuits as well. So that's that last circuit, or the last couple circuits that we explored. Okay? We'll hit a pause on this now and we'll regroup and come back to another type of circuit later on. All right, that's it.